Hello and welcome back to the second part of my four-part series of speculation and discussion about historical aircraft. As we mentioned in the previous introductory video, this will mainly be concerning the Me-109. Today we're focusing on the front of the plane, the big spinning part that stirs the air, called a propeller. One of the most common questions I've heard asked, and that I've asked myself for improving the performance of the Me-109 and Nazi aircraft in general, is the lack of four-bladed propellers. Why don't they use a four-bladed propeller? So today we're going to explore a little bit into the world of propellers, the engineering that goes into their design, and the complications of changing from a three-bladed propeller to a four-bladed propeller. There's a few factors that determine how good a prop is at being a prop. Namely, the pitch, the surface area, the RPM it's spun at, and the airfoil's shape. The Germans' three-blade propeller was very finely tuned, in shape and surface area especially. So finely tuned that if they converted to a four-blade propeller, they would only gain roughly a 5% increase in performance. This is in part due because a four-blade propeller adds drag. More drag means lower RPM, which means lower effective surface area, even if the actual surface area increases, because effective surface area is a function not just of actual surface area, but of the speed that surface area is spun at. So even if a four-blade propeller has more surface area than a three-blade propeller, the drop in RPM would reduce the amount of that surface area. And it would not necessarily mean a net gain in motive force. Take the Wright brothers plane, for example. It had one engine that made like 12 or 16 horsepower, if I remember right, not a whole lot. And they used some bike chain, if I remember correctly. Anyways, they used one engine to spin two-bladed propellers. If you went and slapped on some fancy new lightweight high-efficiency carbon fiber 5-blade propellers, the increased drag from having 5 blades instead of 2 means that the propellers would spin much slower, and if slowed by a large enough margin, could actually move less air and maybe not be able to fly anymore. On top of that, you also have to consider the shape of the airfoil. The shape of the airfoil is important for optimizing performance at specific altitudes. As a quick example, have you seen those C-130s that have 6-blade curved propellers? At high altitudes, there's less air resistance, so there's less drag, and they can spin those props faster at higher altitudes in thinner air than you could at lower altitudes, thus increasing effective surface area. But at lower altitudes, the thicker air makes for more drag, reduces RPM, reduces effective surface area. Not necessarily because of gearing and horsepower and torque and stuff, but in general terms, fewer blades with more surface area is going to be better at lower altitudes. That's part of why the Russians had so many three-bladed propellers on their aircraft. Their planes were generally optimized for lower altitudes. And by optimized, I mean there was other things besides the propeller, like the ratios for the superchargers and turbochargers, the fuel mixtures they used, and so on. Inversely, more blades of less surface area will be better for higher altitudes, like the P-51 and the Mark 9 Spitfires, with four-bladed propellers that had long, narrow blades. Those were excellent for escorting high-altitude bombers. The C-130 from the earlier example with the 6-blade propellers is an extreme example of that. This works in the other direction too. The little Cessnas and Piper Cubs that you see in general aviation still run two-blade propellers, mostly, because the little unpressurized planes, mostly, don't go above 5,000 to 7,000 feet, and their little engines are more worried about fuel efficiency, longevity, cost-effectiveness, rather than torque and horsepower and speed. So they stick with two-blade propellers instead of going to 3- or 4-blade propellers that would cause more strain on the engine, even if, in theory, those would offer better speed, better rate of climb, etc., etc. Other examples, some of the great 1920s and 1930s race planes used inline 6-cylinder engines, which, sure, those were a little bit more aerodynamic than the 5 and 7 and 9-cylinder radials that they were competing with, but inline engines make a great torque. So they could spin 3-blade propellers at higher RPMs for more sustained periods of time than others, allowing them to squeeze just a little bit more efficiency out of their air screws. And when you're racing, those tiny, 0.5% margins matter. A propeller is essentially spinning wings, and just like wings, the cross-sectional shape and the length and the taper of the airfoil is important as well. So all of those things combined are part of what I mean when I say that they had the three-blade propeller well optimized. But there's other factors involved in the implementation of a propeller, not just the engineering behind the design of the hardware. You must take into account all the logistics of building these propellers and installing them on the existing airframes. Because of the Germans' common use of guns that fired through the propeller hub, they'd have to build a whole new hub in order for a new four-blade propeller to be used, which could be done in one of a few ways. The easier solution would be to make the hub larger in diameter, but that would mean modifying the cowling and the shape of the cowling over the engine. So there's a ton of retooling and different production lines and such that you have to do to meet that demand in order for the cowling to mesh with the hub of the propeller. So not only are you making a new propeller, but now you have to make new versions of all the skin panels around the engine / nose of the airplane. The other two options are to use smaller, more expensive, more delicate, less reliable parts in order to make a four-bladed propeller hub that fits inside the same hub as the three-bladed propeller. And the Nazis, with the Americans, the British, the Polish, the Canadians, the French, the Russians, and everyone else pressing in from all sides, they couldn't afford more expensive or less reliable hardware. The third option would be to use the same size parts and build the same sized hub for the four-blade as you would for the three-blade, just without the hole in the middle for the barrel of the Me-109's main weapon. And with only 3 guns in its standard configuration, they weren't willing to give up the firepower of the centerline cannon in order to make a four-bladed propeller of the same hub diameter either. So, it's another case of damned if you do, damned if you don't. On top of that, as I think I already mentioned, their three-bladed propellers were, well optimized. They started with these three-bladed propellers back in the 1930s when they were designing the Me-109, back when it was still called the BF-109. As I mentioned in the previous video, the BF-109 was designed in 1934. And here's another fun fact. Aircraft made before 1938 are called BF-109. But in 1938, Mr. Messerschmitt gained the majority shareholding of the company and took control, so anything and everything manufactured after 1938, even though they're the same aircraft from the same BF production line, they were given the ME moniker instead. So the BF-109 and the Me-109 are the same aircraft, but it's only a BF-109 if it was manufactured before 1938. By the end of the war, they were getting desperate and looking at any and all possible solutions to give them an edge, and they had more than a decade of active combat development and experience in the design of this plane. The cross-section, the length, the shape, the width, the taper, the diameter, the height, and everything else had been so carefully honed with these three-blade propellers that they were only looking at a 5% performance boost with a four-blade propeller over the three-blade propeller. So, while change to a four-blade propeller might seem like an obvious, simple solution for a performance improvement, and indeed I think it is the most commonly pointed out thing that could have been done to give the plane more of an edge, given the circumstances, it wasn't really an option for the Luftwaffe, or at least not a feasible one. Their increased cost, reduced reliability, and or reduced firepower for only, at best, a 5% increase in oomph isn't worth it. So that's why they didn't do it. Because the cost of redesigning propeller hubs, possibly losing their firepower, retooling all those production lines to build new propellers or engine cowlings, it wasn't worth the minimal increase in performance. Especially in 1944 and 1945, when they really needed the extra performance, because there wasn't any meat left on the bones of the German economy to keep fighting the war. In the next episode, we'll continue this discussion by going over the aforementioned firepower, because that cannon that fired through the propeller hub and the engine's hollow crankshaft always interested me. And while it may have been the plane's main weapon, it was not the only weapon. So next, we can talk about the Me-109's weapons stacked up compared to the Americans' airborne firepower, and discuss what, if anything, could have been done to try and level the playing field between the Axis and Allied aircraft. If you're enjoying this kind of more, engineering, mathematical deep dive into historical topics, and me not focusing so much on scientific theory or video games, then please leave a like or a comment down below and help drive the algorithm so I can figure out what to do. Because the YouTube algorithm is often changing and it's impossible to make heads or tails of. So join me for part 3, where we talk about the bits of airplanes that fling metal at other airplanes. Also, I'm a science fiction author, and if you haven't seen or heard, my book, The Descendant, is available on Amazon, and the link for that book will be down in the description. It is the first book in a series, and there will be more in the future. The other books are written. We're just waiting on the editor to help get things sorted out. You can also find me on Twitter, Facebook, Instagram. I have a couple websites. I run a blog. So if you like, you can find my blog, where I talk more specifically about writing and the book and the story in the book and all the lore and world building that I do. So I will have links to all of that down in the description. Alright. Speaking of firepower, that took a lot of my ammo. I don't have a whole lot of ammo left, so I'm going to take this thing back to base and rearm. See you guys in the next one, where we talk about guns.